Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have the integral of 1 over x cubed minus 1 dx. Now this is the beginning of one of those challenging integrals. I was requested by one of my students to say that please bring up a bit more challenging questions. So this is the start. So this is one of those integrals that will take us a bit of time to evaluate, but let's see how we go about it. So it's the integral of 1 all over x cubed minus 1 dx. Now, if you look at the denominator there, we have the difference of two cubes. Factorizing this is how we do it. 1 all over the cube root of x cubed is x. The cube root of 1 is 1. In one bracket, we maintain that minus sign. And then we get to the other bracket. We're going to work on this now. We take this, we square it. The answer is x squared. We take x and 1, multiply the 2, the answer is x. The sign here is minus, we must change the sign there. And then we take 1, multiply by itself, the answer is 1. And then we have dx. Expand this to verify it, expand this, it will give you x cubed minus 1 when you expand and simplify. Now we have to decompose the integrand by using partial fractions. So we have 1 all over x minus 1 and then x squared plus x plus 1. This should be equal to, remember rules of partial fractions, x minus 1 is linear, and therefore the numerator there, when you break it down, it has to be a constant over x minus 1. And then x squared plus x plus 1 is a quadratic expression. The numerator will be linear expression. So this is bx plus c all over x squared plus x plus 1. So we have to determine what a, b, and c are. We simplify the right-hand side. I'm going to move back a little bit because of space. We are basically saying what is the LCD, the lowest common denominator of the two denominators. You just have to multiply them. So it's x minus 1. The other bracket must contain x squared plus x plus 1. And then what do you do next? You divide this one here into that denominator. The answer is x squared plus x plus 1. So we have to take this, multiply by the numerator. Remember, this cancels that. You're left with this one. Has to multiply with the numerator. So a times x squared plus x plus 1. And then plus, when you take this, divide into the denominator, the answer will be x minus 1. Multiply by the numerator. So we are saying bx plus c, multiply that by x minus 1, like that. Fantastic. Now on the left hand side, remember, we have x minus 1 and then x squared plus x plus 1. In the numerator, we have 1. Now see, we have two fractions here that are equal. Denominators are equal, therefore numerators must also be equal. So I can say here now, therefore, that expression must be equal to 1. So we are saying a, and let me expand this. It will be ax squared plus ax plus a. And then expanding that, we have plus bx squared, bx times x, bx squared, bx times minus 1 is minus bx. And then we have c times x is cx, c times minus 1 is minus c. What is this equal to? The numerator there is equal to 1. Now I'm going to put like terms together here on the left. So I have a x squared plus bx squared. I'm done with this term and that term. And then I'm moving to terms containing x. It will be this one here, that one, and that one. So we are saying plus ax minus bx plus cx. And then constant terms are 2, this one and that one, plus a minus c. The answer is 1. Now I'm going to have to factorize on the left hand side. So what do we have now? We have a plus b x squared plus This part here, it will be a minus b plus c times x, and then plus the constant terms a minus c. The answer is, watch how I'm going to write 1. I'm going to write it as 0x squared plus 0x plus 1. Why is this important? Because now I want to say equate coefficients. That must be equal to 0. And this part here will be equal to the 0, the second term there, coefficient of second term. And the constant term, the whole of that must be equal to the constant term there, which is 1. So basically we are saying a plus b equals 0. And then we have a minus b plus c equals 0. And then finally we have a minus c is equal to 1. Now we make a as c subject formula here. We're going to say a minus 1 equals c. Basically we are saying c equals a minus 1. Now bring this one there. In the place of c, put a minus 1. So we have a minus b plus a minus 1 equals 0. Rewrite this equation here. You'll agree with me that this is 2a minus b. The answer is 1. And take that equation there. So we're going to have 2a minus b equals 1. We add these up. That will be 3a. The b's cancel. On the right hand side, I have 1. And therefore, you can agree with me that a is actually 1 over 3. So we have the value of a now. And to find the value of b, you move back here. Find the value of c, you come back there. So let's take this to page 2. Right, so now I'm saying, to get the value of b, you come here. 2a minus b equals 1. What is a? A is a third, so 2 times 1 over 3 minus b equals 1. This is 2/3 minus b equals 1. Minus b equals 1 minus 2/3 minus b equals, if you check, this is just 1/3 basically. And multiply by minus 1 both sides, b will be equal to minus 1 over 3. And then move to the second part. The second part, the last part is this part here. What is c? C is a minus 1 over, minus 1 actually. So what is a? Well, a is 1/3. Here it is. So this is going to be 1/3 minus 1. And the answer is minus 2/3. So now we know the values of a, b, and c. So we go back here. This expression here should be replaced by that. So basically we're saying this integral should be, this part here changes to that, and then we have dx there. So we are saying basically, therefore, this integral here, which is 1 all over x minus 1, and then x squared plus x plus 1 dx is actually equal to the integral. Remember, we're coming back here. What's the value of a? It's a third. What's the value of b? Minus 1/3. Here it is. What's the value of c? Minus 2/3 all over that. So we're saying we have 1 over 3 all over x minus 1 in brackets like so. And then we have to have plus, because we have a plus sign here. There it is. Minus 1 over 3 x minus 2/3 all over x squared plus x plus 1. And then we have to say dx. Right, so this is how we change this integral here. Now let's simplify this part now. So simplifying this, distributing dx and the integral there, we have the integral of 1 over 3 all over x minus 1 dx plus the integral of this part here, which is minus 1 over 3 x minus 2/3 all over x squared plus x plus 1 dx. Now, of course, I'm going to have to factorize the numerator here, and I'm going to have to take 1/3 out because it's a constant. So basically, we are saying 1 over 3, the integral of 1 over x minus 1 dx. And then this part here is going to be plus the integral of, take 1/3 out, and then you're going to have x plus 2 basically, all over x squared plus x plus 1 dx. Right, now we're moving forward. Let's take this to page 3. Taking this to page 3 now. Remember I told you this is one of those integrals a bit more challenging than the other integrals we've looked at so far. So this will change to 1 over 3. I'm going to keep this one for a moment. 1 over x minus 1 dx. But this part now I'm going to take 1/3 out. It will change that to minus 1 over 3 integral of x plus 2 all over x squared plus x plus 1 dx. Now, fantastic. So now, this part here, I can work on this. I'll say, let u be equal to x minus 1. Therefore, du dx, you'll agree with me that the answer is just 1. Derivative of x with respect to x is 1. Derivative of minus 1 is 0 because it's a constant. Multiply by dx both sides, you're going to get du is equal to dx. So this integral then changes. That I'll keep it the way it is. That one now changes to 1 over 3, the integral of 1 over u du. Remember, u is x minus 1, and then dx equals du, like this. But we have to say minus 1 over 3. Allow me to say I1 now, because we're going to have to evaluate that on its own. But the first part here is 1 over 3 times the natural log of u. You remember that. And then minus 1 over 3 I1. Now, why I1? Because we're going to have I2 in the process as we go. Let's simplify this further. This is 1 over 3 natural log of, remember, this part here, u is just x minus 1. So we must maintain that. Right, then minus 1 over 3 I1. Fantastic. Now we have to work on I1. So what is I1 equal to? Well, I1 is the integral of x plus 2 all over x squared plus x plus 1 and then dx. Fantastic. Now, if you look at the denominator here, differentiating this, you get 2x plus 1. But we have x plus 2 in the numerator, so I need 2x there. And then we'll have to create or manufacture a 1 somewhere there. But if I multiply the numerator by 2, without changing this, I will have to divide by 2. So basically, I'm saying this is 1 over 2, the integral of 2x plus 2, like that, all over x squared plus x plus 1 dx. Remember, you can cancel these 2's, but we don't have to cancel because we expand the numerator now, and then we produce at least 2x, which we get when we differentiate this part. But that, if you differentiate that, it will be 1. So we'll have to split whatever we get there into 1 plus something. Remember, derivative of 1 is 0 because it's a constant. Right, taking us to page 4. So basically, we're saying on page 4, right, we're now saying that integral is equal to 1 over 2, the integral of 2x plus 4, all over x squared plus x plus 1 dx. Fantastic. Now you see there, we have 4. We have to split that. So this is going to be 1 over 2, the integral of 2x plus 1, and then plus 3, all over x squared plus x plus 1 dx. Now I'm going to use term-wise division. I'm going to divide this expression into that one first, and then into 3, keeping half out. So 1 over 2, the integral of 2x plus 1, all over x squared plus x plus 1. And then I'm going to say plus 3 all over x squared plus x plus 1. Remember, dx. Because that's what this is. Term-wise division. You divide this expression into that and that. And then this part, distribute the integral and that, keeping a half out, 1 over 2. And then we're going to say integral of 2x plus 1. Allow me to do this and say dx there, all over x squared plus x plus 1. And then I'm going to use a bracket out there, plus the integral of 3 over x squared plus x plus 1 dx, like so. Fantastic. Now I'm going to distribute the half. So this is going to be 1 over 2 integral of 2x plus 1 over x squared plus x plus 1 dx. And then here I'm going to have, take the 3 out. So it will be 3 over 2. There has to be a plus sign here, not is equal to. We have to have a plus sign there. It's that plus sign, right? So 3 over 2, the integral of 1 all over x squared plus x plus 1 dx. Nice. So this, like I said, I'm going to put a plus sign there in a moment. Now, so let's work on this part. So this part here, we are basically saying, yeah, everything is fine. So we're now saying we're going to let u be equal to this part, x squared plus x plus 1. What is du dx? Du dx is going to be equal to 2x plus 1. Remember, derivative of 1 is 0. Multiply by the x both sides. Du is equal to, in brackets, 2x plus 1 dx. Fantastic. If you look at this expression, is that expression there, the numerator combining with that, which is just what you see there. Right, so here I said you have to have a plus sign because of that sign there. Nice. So now let's work on this one, and then we're going to have I2 coming out of there. Remember I told you we had I1, now we have I2 coming out. So let's proceed. Now, taking us to page 5. I told you this is one of those integrals a little involving, so one has to be patient. Right, so now we are saying that integral changes to, this integral now changes to half. Remember, 2x plus 1 dx is basically du. In the numerator, I'm going to have u. So now we have 1 over 2. Let me put this one up. I want page 5 to be seen. And I'm going to move this one down. Right, so now we are saying that integral now changes to 1 over 2, the integral of du all over u, plus 3 over 2, and then we're going to say I2. Now, let's work on this. So this is going to be 1 over 2 natural log of u plus 3 over 2 I2. Fantastic. Now, let's work on this one here. So this is going to be 1 over 2 natural log of, what is this u? U is basically x squared plus x plus 1. So, and I'm going to show you later why I must drop the absolute value signs now. Because this expression here, I'll show you, this can never be negative. So we just have to say x squared plus x plus 1. And then plus 3 over 2 I2. Nice. Now let's work on I2. What is I2? It's this part here. So now we are saying I2 is equal to the integral of 1 all over x squared plus x plus 1 dx. Now remember, this one now, as you can see, requires us to complete the square of the denominator there. So I'm going to focus on this part here first. Remember, if we are to complete this, express that as a perfect square, we have to say x squared plus x plus some constant k. The answer will be equal to the square of a bracketed expression. Square root of x squared is x, and then plus some constant a. We have to determine a in terms of k. Expand the right hand side, you're going to get x squared plus 2ax plus a squared. This is equal to x squared plus x plus k. The first part you can see is taken care of. Coefficient of x on the right must be equal to coefficient of x on the left. So 2a equals 1. What's a? 1 over 2. And then bring this one this side. K equals, that equals constant at the end there. Remember, it's supposed to be a squared when you expand that. It will be x squared plus 2ax plus a squared. If you expand that, you're going to get that. So this is a squared. And what does this give us? It gives us 1 over 2. We have to square that, and the answer is a quarter. Nice. So basically we are saying Now, this expression here can change to x squared plus x plus a quarter. And this can be written as, go to the right hand side, x plus, what is a? You can see here, a is half. So this is 1/2. We square that. Nice. So this integral then can be transformed as follows, taking us to page 6. This integral can be transformed as follows. Taking us to page 6, almost done now. We're basically now saying, this integral then, therefore, I2 is just going to be equal to the integral of 1 all over x squared plus x plus a quarter. But I have 1 here. Remember, plus a quarter because I want to complete that into a perfect square. But there's a 1, so I'm going to have to say plus 3/4 because a quarter plus 1 is 3/4. Now, moving forward, we have the integral of 1 over. Watch, this part now would be replaced by that. So I have x plus half, and I have to square that plus 3/4 dx, right? If you haven't watched one of my previous videos, please go and watch one of the videos. I've spoken about which integration technique should I use. We're talking about trig substitution there and the tan one. Here you can clearly see that there's something squared plus something. I need to have a 1 here, so I'm going to force this to be the common factor in the denominator and factorize as follows. So we're saying the integral of 1 all over 3/4 is a common factor, and I'm going to say 3/4 into this one. It will be x plus half all squared divided by 3/4 plus 3/4 into 3/4 1 dx. So I have to simplify this part now. Remember, when you're dividing a fraction, the 4 must go up and the 3 must come down. And this one is dividing into 1. So when you take it out, it will be 4 over 3. So this is 4 over 3, integral of 1 all over. This part now, it will be 4x plus half squared all over 3 plus 1 dx. Now I'm going to rewrite this part here as follows. So this is going to be 4 over 3, integral of 1 all over. This part here, I'm going to take 4 in, but it has to be 2 because remember we have to square. So it's going to be 2x plus 1 over 2. And then I'm going to say, watch this, I'm going to say all over square root of 3. The whole of this has to be squared plus 1. Fantastic. Now, do some algebra here. This is simple algebra. Work on this one here. If you remove these brackets, you're going to have 4 there and you're going to have 3 down here, which is exactly this one. But now I have to expand the numerator there. So it takes me to the following expression. It takes me to 4 over 3, the integral of 1 all over, watch this, multiply by 2, the whole of that, it will be 2x plus 1. If you expand those brackets, 2x plus 1, and we're saying over root 3, and I have to square this, plus 1. Fantastic. Dx. Now I can use tan substitution. Taking us to page 6. Taking us to page 6. I'm going to have to use tan substitution there now. What am I saying? Don't give up. Let's just carry on. Let's see how far this one can go. We're almost there, by the way. Page 7. So now we are saying we're going to now let tan theta be equal to this. Tan of theta be equal to 2x plus 1 over root 3. Right. The first equation to obtain from here, it's going to be, so for theta, it's going to be tan inverse or arctan of 2x plus 1 over root 3. The second equation is going to be to differentiate both sides, but I'm going to have to multiply by root 3 first. So it will be root 3 tan theta is equal to 2x plus 1. You agree with me? If you multiply by root 3 both sides, this is what you get. Now let's differentiate both sides. It's going to be root 3. Derivative of tangent is sec squared of theta, and I'm going to say d theta. On the right, remember, we're just going to say 2 d theta dx. The derivative of 1 is 0, it's a constant. Divide by 2 both sides. Root 3 over 2 sec squared theta d theta. The answer is equal to dx. Nice. Now, we would have to transform this integral now. So we're basically saying this integral now, which you can see, transforms into 4 over 3, the integral of 1 all over tan square root of theta plus 1 times root 3 over 2 sec squared theta d theta. You agree with me? You have seen so far, this is sec squared. Cancel that. And then take root 3 over 2 out. So it's going to be 4 over 3 times root 3 over 2 integral of 1 d theta basically, because this cancels and you only have that one left. This comes out. This is what you have. Now let's simplify this outside here. Simplifying this outside here, taking us to page 8. Page 8. Now simplifying that, what do we get? You agree with me? This goes there 2 times. So we have 2 root 3 over 3 times integral of theta is just theta. Now this is 2 root 3 over 3. What is theta? Theta is here, tan inverse of 2x plus 1 over root 3. So this is tan inverse of 2x plus 1 over root 3. Fantastic. Now we have to move back. Remember, this is I2. This is I2. We started from here. That's I2. So we have to move back to where? Where we stopped at I2. We have to move back to an expression containing I2. Let me go back to which page? Here is the page. Look at this. It's half of that plus 3 over 2 I2. So we're basically saying, therefore, I1, remember this is I1. So where did we start from? I'm going to show you where I1 is. We have page 3. Here it is. I1 was this integral. I1, remember we have a third I1. So we have to work out I1 first. I1 starting from here and continuing and ending there with I2. So we're going to say I1 is equal to, we're here now, half natural log of x squared. By the way, I've been able to show you that this is always positive when we were doing completing square of this. Let me just show you. I'm going to take you back to where I completed the square of that. Here it is. You can see this part here. This part can never be negative. This part is exactly x squared plus x plus 1. Remember, this is where we're coming from. We're coming from there. So that can never be negative. Let's proceed. So now, where are we at? We are here, and we want to just complete that. So plus x plus 1, and then plus 3 over 2 I2. Now what is I2? Well, I2 is this expression here. So I'm going to rewrite this part because I don't have space there. Maybe I can try. No, I don't think it will fit. But let's try and see if it fits. Times 2 root 3 over 3 tan inverse of 2x plus 1 over root 3. Nice. Now let's simplify this. This cancels that and this cancels that. So we have root 3 there. Right. So now we are basically saying this is 1 over 2 natural log of x squared plus x plus 1 plus root 3 tan inverse of 2x plus 1 over root 3. Nice. Now that's I1. So we must move back to get our original integral. Now we're taking that expression. We're going back to where? We're coming back to, this is page, we're coming back here. There. Remember, I1 is this place here. So we're going to take this one here and we're going to put it there, and then we are done. So basically we are saying our integral, therefore, our integral of 1 all over x cubed minus 1. Remember, this is where we're coming from. Dx must be equal to, I'm going to start far away on the left. I'm going to write this part first, 1 over 3 natural log of x minus 1. And then I have minus 1/3, 1 over 3 times I1. What is I1? Where I1 is this one that you see, that one there. And then I'm going to say times 1 over 2 natural log of x squared plus x plus 1. And then plus root 3 tan inverse of 2x plus 1 over root 3, and then we have to say plus c. But let's just write it formally now as a conclusion. So we're saying this is the same as, let me start a bit far on the left, is the same as 1/3 natural log of x minus 1, like that, and then expand this out, distribute the minus 1/3. So you will agree with me that we minus 1 over 6 natural log of x squared plus x plus 1, and then multiply this out by that, it will be minus root 3 over 3 tan inverse of 2x plus 1 over root 3, and then we have to say plus c. Now, I was requested, like I said at the beginning, to bring up equations, integrals that are a little bit more challenging. So this is the first of the many challenging integrals that I'll bring up on this channel. So this is the final solution to that so humble looking integral, the integral of 1 over x cubed minus 1 dx. Remember where we're coming from? We're coming from this integral here. Just want to show you the original page that contains the integral we've been focusing on. This is the integral we've been focusing on. This integral, the final solution is this one here. Tell me what you think about this integral. In my next video, I will bring up one where there's a plus sign here, and then we'll bring many more involving integrals. Yeah, I want to stop here. I'll see you in the next one.